Hello everyone and welcome to our session today, Fun and Games, and why we picked ClickHouse to drive gaming analytics at GiG. Throughout the session today, we'll be going through who we are and introducing ourselves, the stock take of the legacy technology in place, the research that was conducted and what formed part of the research, the approach that we took, the infrastructure that was needed, and of course what we intend to do more in the future. My name is Stephen Borch. I'm the Director of Data at GiG, where I have a career in the gambling industry, where I was either developing or leading teams around technology for both B2C and B2B.
Hello everyone, I am Matthew Formosa. I am the Enterprise Data Architect here at GiG. My career has essentially led me to develop a passion for data, enthusiasm to delve into new technologies, and eagerness to face challenges and take on new opportunities.
So let's first start with the stock take and what made us even consider building a new platform. So if we had to look at what our insights and what our data was based on, it was based on complex traditional data warehousing techniques, where complex ETLs prepared data for business intelligence. These complex ETLs took many hours to complete, and of course, by the time these were done, data was already stale. Data growth was also an issue due to linear growth. And of course, due to the cost base continuously increasing around data storage, new data sets weren't added. Two of those data sets as examples were social media and scraping metadata off sites. One of the biggest pain points was also being slow to adapt. And of course, due to all the regulation changes around the gambling industry, this was a huge issue. We're also struggling to personalize content for our customers due to customer demands always on the rise. This is not just us. So if we had to consider why are so many companies looking to upgrade their data capabilities, if we had to look at the main reasons, we did not really consider that the technology that we had in place was viable for our business growth. Many times we were hitting the limits of traditional relational databases, and of course, there was only so much we could do with optimization. We ended up throwing people at the problem, and of course, this isn't sustainable long term. The legacy technology was too expensive, complex, and cumbersome to maintain. And as a result of that, utilizing machine learning and artificial intelligence was deeming to be impossible. With all the competition out there, we didn't really want to offer a platform which was based on data that was a day late. And of course, we wanted to move from being reactive to proactive. So we drafted must-haves that the new platform should have. And if we had to bucket them into 6 categories, these would be those 6. Of course, we started with the need for having real-time information. We needed to be able to make ourselves ready for use cases to predict customer value, to predict if a customer has bad habits around gambling. The cost base. Maintaining the cost base and making sure the cost base is predictable so the platform is sustainable long term. We wanted to make sure that the skills that the team has is able to maintain the platform at a good pace and have a technical debt which is healthy for the platform. Apart from that, we wanted to make sure that we understand how the product is being used, understanding the data lineage, and making sure we have in-depth know-how of who's accessing information, who's exporting information, and making documentation available for the platform. As I said earlier, the adaptability is key, especially in our industry. So to support the compliance area of the platform is very important. So for us to adapt change and support newly regulated markets, this was deemed to be key as well. And last but not least, making the platform machine learning ready. And by this, of course, we mean having our data analysts and data scientists making the most out of the platform itself.
So moving on to the research carried out. In order to appreciate the research that we carried out, obviously we have to start off by discussing where we are coming from. So a couple of years back, we were making use of Hadoop technology and the Hadoop ecosystem, and we were leveraging managed services to address the complexity of Hadoop. Obviously, Hadoop and managed services have their limitations, and that led us to then consider data-driven Lambda architecture on AWS Cloud. On AWS Cloud, we were ingesting data from source and staging it on S3 buckets. Then we had daily Spark jobs and Hadoop jobs running on EMR cluster, which were provisioned on the fly and also contributed to our ETL, essentially. Data was then loaded to our data warehouse, which on AWS was Redshift. So this is a very high-level component diagram of what we had on AWS Cloud. So our source was Kinesis. Then we had serverless applications running on Lambda. Lambda were feeding data to Firehose. Firehose was then propagated data to S3 buckets. And then our EMR cluster, which was our ETL essentially, ran daily Spark jobs, which would take that data from S3 and prepare it for staging and then load it into Redshift with other separate Spark jobs and Hadoop jobs. So what did we want to achieve? So first of all, we want to simplify our architecture. Although that might have seemed like a very simplistic architecture, there were still too many moving parts and points of failure. Also, we wanted to further reduce our costs, as always, and we wanted to enable real-time data analytics. As Stephen mentioned, we were always still a day late. So moving on to the use cases we had, again, we wanted to calculate real-time KPIs. So when it comes to NRCs and NDCs, we wanted to make these available immediately to our partners and business. And this also includes lifetime aggregates, such as how many bets were placed, how many wins there were, etc., etc. This would also allow us to enrich our dashboards with the latest data. So analysts can just go and see the dashboards with the most recent data available. We wanted to empower AI models with real-time data to provide immediate customer predictions, such as customer segmentations, as early as possible upon registration, customer tagging when it comes to fraud and AML, etc., etc. And also we wanted to enable the business and our partners with quick and easy access to their most recent data to allow them to make the best, most informed business decisions. So what technologies did we consider? Apart from the technologies I mentioned before, Redshift and Hadoop, here at GiG, we looked into Druid, Pinot, and ClickHouse. And here we are capturing the metrics vis-a-vis the technologies we considered throughout our years. So starting off with infrastructure, setting up, provisioning, and stability. Then we consider skills and ease of use. Moving on to latency when it comes to data ingestion. Change management when it comes to schema evolutions. The support for native Kafka. And whether the technology is proprietary or not. So looking at ClickHouse, you can immediately see that it met all of our needs. Druid was a very strong candidate, but it had its own repercussions when it came to setting up and understanding the technology behind. Hive wasn't that much of a considered technology. As you can see, it wasn't that easy to use and didn't have native Kafka support. Pinot, we have to keep in mind here that we considered Pinot back at a stage where it was still incubating and it didn't meet our needs at all, practically. And Redshift, which was our previous data warehouse, still a strong candidate, but it doesn't have native Kafka support and it isn't proprietary. So why did we choose ClickHouse? First of all, the most important point to mention here is the simplicity of ClickHouse. So when it came to Druid and Pinot and ClickHouse, we considered the same use case throughout. So we wanted to ingest data from Kafka and store it in a table. With ClickHouse, this was immediately achievable. ClickHouse is also very feature-rich. It has its own specialized engines, which allow us to keep the latest state of entities and also aggregate data on the fly. It is also a functional-like programming language, so to speak, like Scala, and it has its own array functions and other functions which we deem necessary in our day-to-day querying. It is also very well documented, and it has a strong community behind it, so support is always available. Moving on to our approach, starting off with schema design. So we wanted our schema to be very self-explanatory without the need to having a lot of data dictionaries around our schemas. We wanted to have less schemas throughout, so this would limit the number of joins required. As you can appreciate, in big data, joins are very expensive, and it's the same thing with ClickHouse essentially. So we wanted to keep our schemas as flat as possible to help make use of better resources. And we also made use of inbuilt dictionaries in ClickHouse within our views for quick retrieval of dimensional data. So essentially here what's happening is that data is loaded into memory and then made easily accessible when needed for querying. So in ClickHouse, we set up a three-layer architecture. So this is very high level here. We have stage, data warehouse, and marts, which I'll be going through in the next slides. This is a component diagram of essentially what we have now, and you can appreciate what we had before. So now we just have Kafka as our source, and we have the staging layer in ClickHouse, which reads from Kafka with the use of Kafka engine. Then we have the data warehouse layer, which is a transactional layer reading from the stage layer. And we have the marts layer, which builds on top of the data warehouse layer. And if need be, then we push data back to Kafka for other clients. Starting off with the stage layer. So the stage layer, as I explained, is ingesting data from Apache Kafka, which is our main source of data. We are immediately eliminating duplicate data within the same batches, and we are distributing data between shards. Within the second layer, the data warehouse layer, here we are reading from the stage layer through the use of materialized views, and we are applying an integrity check to prevent duplicate data. Although this is a very expensive step in our data process, this is crucial because our data flows cannot afford to have multiple data. So if we have lifetime aggregates as KPIs, you can understand that if you have duplicate data, the lifetime KPIs aren't going to be correct. And this is essentially the transactional data store of all our entities. So here we store all our game spins, the payment state changes, all the customer changes, customer blocks. It's practically the audit of all our entities. Finally, we have the marts layer. The marts layer builds on top of the data warehouse layer. As I explained, it stores the latest state of all our entities. We also aggregate data on a daily and monthly basis. So here we have, for example, games aggregated daily and balances aggregated daily and monthly. And we also have revenue figures aggregated on a daily basis, amongst other KPIs. And the marts layer is also the single source of truth of our KPIs. So when it comes to dashboards and reports, they make use of this layer essentially. Moving on to schema evolution. So as we mentioned before, change management was one of the important key points we considered, and we achieved schema evolution through the use of a custom Java Spring Boot microservice, which essentially applies flyware migrations under the hood. And these are all backed in source control. Finally, infrastructure. So first of all, we considered data distribution to have horizontal scaling. As you can appreciate, vertical scaling can prove to be very expensive, especially with so much data. So we wanted to make better use of our resources and went for horizontal scaling. This allowed for faster data crunching, and we considered 5 shards to be deemed appropriate for our data volumes. Another important aspect is data replication. So we wanted to have high availability and fault tolerance. And for this case, we have two replicas for each shard. which essentially amounts to 10 nodes for our entire cluster. Resources, so this is our production node, for example, here. We have 16 cores per node, 94 gigabytes RAM, and 2 terabytes risk per node. And obviously we have more areas where we wish to contribute in the future. So security and access control is always one of the most important things to consider, essentially. It is a relatively new module, and we appreciate that it's still a new module. In fact, we still have a lot of work to do in this area when it comes to ClickHouse. We would like to look into integrations with various authentication providers, even our own authentication providers here at GiG. And this will allow us to achieve a security overhaul whereby we'll have role-based access control with our own GiG authentication provider and a proper role-level security. And that's all from our end. If you have any questions, feel free to get in touch.
Thank you very much, everyone.